Hello and welcome. This is Alister Christie, and today we're going to have a look at writing a DLL and using it. I'm not an expert with DLLs, but I'm currently working on a project that requires one. I hope to be able to share this project with you shortly, and hence this movie on DLLs. Anyway, on with our feature presentation. Here is my example application that we're going to start with, and it is a mortgage calculator. Now if I just run that, you'll see that we can calculate on $100,000 principal, 8.5% interest over a term of 10 years. Your monthly payment would be sort of $1,200, and you'd be paying $49,000 in interest. If you take that up to say 15 years, you're now paying a total of $77,000 in interest. Now I've written this in a special way. If we go to the, in fact, let's first of all look at the source to this. Basically, you'll notice that there's no declarations of all the labels and stuff. That's because this form descends from my calculator base form. And let's have a look at the calculator base form. So I'm using form inheritance here. So here are all my labels and things, and I noticed a few minor mistakes. So for instance, I can go in here and change the caption to just principal and interest, and say change this to payment frequency, and make that a little bit wider. And if I look at my calculator form, those changes have propagated through automatically, because we can see that I descend from calculator base form, and the base form has all these controls on it. So on the base form, in this calculate button, I've got this set of code which calls a function calculate mortgage payment, and this is where the interesting stuff happens. But we'll notice if we go up to calculate mortgage payment that it is declared virtual and abstract. So there's actually no code on this form for this calculate mortgage payment. And if I go up to the project options and make my base form the main form and run it and click calculate, I get this abstract error because well, the calculate mortgage payment doesn't exist. So let's go back and swap that back and go to the calculator form, and notice we've got this function calculate mortgage payment which overrides the previous one, and basically just does the standard mortgage calculation. So what we're going to do is we're going to take this calculate mortgage payment function and throw that inside a DLL, and then we're going to create two more projects, one for calling the DLL implicitly and the other explicitly, and you'll see how they work shortly. But the first thing we want to do is to create a new project based on a DLL. Oh, maybe we do it this way. Add new project, and I'm blind, DLL, there we go, DLL wizard, and we've got a new blank project. And let's start by saving that off. And we'll call it okay. And what we need to do is, from our calculator form, I'm just going to copy and paste and tie this up slightly, and we need the math unit for the power function. And the other thing we need to do is, we've got this function inside the DLL, but we need to say that we want to export it. exports. And if we compile that, we now have a DLL. Next we want to make use of our DLL, so we're going to create a new VCL forms application, and we don't actually want a new form, or that form in particular, so we'll remove that from the project and add calculator base form. And now that our base form is in our project, I can go into inheritable items and create a new calculator base form. And now let's go and save all that off. Unit 6 will be implicit DLL in the project. Implicit DLL example. Okay, let's go back to the code and I'm sure that used to work before I installed update 3, so I'll just go to the calculator form and grab my definition for that function. Okay, and now all we need to do is make use of the DLL, and to do that we need to add a function declaration, and in fact it's pretty much this one. But what we want to do is to say that it's external and it's stored in mortgagelib.dll, and we might run into some problems with two functions of exactly the same name. It might cause a little bit of confusion, so I'll abbreviate this one to calc mortgage payment. And what I also need to do is say name and give it the name inside the DLL. So we've defined this function calc mortgage payment. It's in mortgagelib.dll and the function is called calculate mortgage payment. So in here we just call calc mortgage payment, principal, interest and number of payments. And let's see if it works. Okay, calculate, and yes it does. And if we look down here and scroll up, we will eventually find that our DLL has been loaded, and it's loaded implicitly because we specified the details for it here. Okay, let's close that. Now, Delphi has a highly efficient way of passing parameters for functions and procedures and things, and it does that using registers. Now, the standard way of passing parameters is using the stack. So if you want to use this DLL with other compilers, you will need to add standard call on the end of the function declaration, and we'll need to do that in here as well. Now if I just recompile this, our application, it won't recompile the DLL automatically and we'll get some sort of nasty error. So what I'll do is I'll go into the dependencies for our project and tick that this project is dependent on the DLL. And if I compile our project, you will see that it builds the DLL first and then our application. So now when we run this, it will all still work. So let's save all that and add a new project. And it's also going to be a VCL Forms application. And we don't want the standard form, but what we do want to do is add the calculator base form just like before. And then a new inherited version of that. Okay, and we'll call this one explicit DLL. And before I forget, get rid of the base form from there so that we're defaulting to our new one. And we should probably call it something a bit different. Calculator explicit DLL, that'll do. Let's go to our source code and again grab our function declaration from the base. Oh, in fact it's probably better to grab it from one of these other ones. Okay, this time we're going to load the DLL when we click the button. Now, to be able to do that, we need a handle for the DLL, and what we need to do is use the load library function. Load library, and it is now we need to check is well, if it's less than or equal to 0, then something's gone wrong, so we'll raise an exception. At some stage we're going to want to unload that DLL from memory, and we use the free library and we use the handle that we got from load library. In this try finally block we're going to try and call our calc mortgage payment function within the DLL, and to do that we need to know what the function looks like. So I'm going to declare a type tcalc mortgage payment, and it's a function. Now if I go to our back to our DLL. And just copy that. So that. So it's a function with a number of parameters and it's a standard call. And what we want to do is declare another variable, and we'll call it calc function, and it's of type calculate mortgage payments. Now what we need to do, say in the address of calc_func, we need to get proc address, and it is from, and our procedure name is happens to be the same as that, so let's copy that. So we get the address of the calculate mortgage payment function within our DLL and assign that to the address of our function. Okay, and if that's not assigned, so if this failed and for some reason, we will raise an exception. Could not find function. And then now all we need to do is call the function. In fact, result is assigned calc function, principal, interest, and number of payments. Let's save everything. And we'll call it explicit DLL. And after all that, I've got my fingers crossed. So let's run it and see if it works. And yay! Okay, we've got one warning here, and we'll make sure we get rid of the warning. Let's run that again. And click the calculate button, and we'll see that our mortgage lib DLL was loaded and then unloaded. So that all seems to be working correctly. So let's close that again. And let's make this fail. If we put a Z in the front there and run it, it all starts fine. When we click the calculate button, we get our exception, could not load DLL. And we can do the same in here. So change the name of our function. And could not find function. So if the DLL isn't present, our application still runs. It's just when we need the DLL that it fails. If we go to our implicit DLL example, and in our declaration here, say, let's do the same things, put a Z in the beginning, and run it. fails straight away. Rather nastily too, actually. So let's terminate that. And change that back. And that's pretty much all I wanted to cover involving DLLs today. So let's go to the summary. Today we started by having a quick look at form inheritance, and then we got stuck into our main topic of DLLs. Delphi makes DLL writing easy, and using them just as easy. Normally if you wanted to split your application into parts, you'd use packages, as they give you much more flexibility. However, you will often need to use DLLs written in other languages, or produce a DLL in Delphi for use with another language, perhaps C++, or you might need a DLL to do something at the operating system level. There are two ways of accessing DLLs, implicit and explicit. When you use a DLL implicitly, you state the function you want to use and what DLL contains it. The DLL will be loaded when your application starts, and it will verify those functions exist. If the DLL or function is not present, it will give you an error and then close your application. I'm not sure why things failed so drastically when I attempted it. When you use a DLL explicitly, you manually load the DLL using load library and find the function you want using the getProc address, and then free the DLL using free library. And as you saw, this is more complex but gives you much more flexibility. For instance, you don't need to know the name of the DLL or the function until runtime. And if the DLL is not present, your application will not fail. Well, that depends on how you code your application, of course. If you're using a string or dynamic array as a parameter, you need to include sharemem as the first unit in your DLL and application. You also need to be aware of the calling convention, and it seems to be always recommended to use standard call. We covered a lot in this video. I hope I was intelligible and at least somewhat coherent. Anyway, thanks for watching. Catch you next time.